This video demonstrates the technique of titration. Titration is used to determine the molarity or the moles of an unknown substance. In this case, we're going to determine the molarity of unknown hydrochloric acid by using a known molarity of sodium hydroxide. So in titration, we use a burette. A burette is a cylindrical piece of glassware which has graduation marks all the way down its barrel. And at the bottom of the burette, you'll see this apparatus called a stopcock. So when the stopcock is in the perpendicular position, the solution does not flow. When it's in the parallel position, the solution can flow out. So with a burette, it allows us to dispense accurately different volumes of liquid, unlike a pipette, which can only deliver a set volume of liquid. So the first thing we do with any piece of glassware that we wish to dispense a known volume of liquid is to rinse it. So I'm going to take my sodium hydroxide titrant and add about 5 milliliters to the burette. So for 5 milliliters, just estimate at the bottom about 5 milliliters. You don't have to completely fill the burette, you just have to have about 10% of its volume, which is around 5 milliliters. And then setting that aside, take a waste container and have your burette horizontal and allow the solution to go backwards through the burette. At the same time, rotate the burette so that the solution touches the sides of all the glassware of the burette. So this was my third rinse. I had actually done 2 rinses prior to starting the video. So with everything, you always do a total of 3 rinses. So now what I'm going to do is to take my sodium hydroxide and fill the burette. If you wish to use a funnel, you can always do that as well. However, you have to ensure the funnel is clean and dry, or has also been rinsed with the solution that you're trying to add. So generally you fill above the 0,0 mark. The reason for doing so is at the bottom of the stopcock there's usually a bubble. So right here we do have a bubble that goes 3 or 4 centimeters down the length below the stopcock. So to get rid of that bubble, I'm going to open the stopcock and then gently tap the burette, and that usually lets the bubbles go down through. So now to read the burette, because it is so high, if I place it back into the burette holder, I won't be at 90 degrees to the meniscus. We're going to use a meniscus reading card, place it behind the burette, and then while your eyes are at 90 degrees, you estimate the reading. The first 2 digits are very easy, so in this case it's between 2 and 3 milliliters, so I would read that as 2 point, and then the first 4 lines are, the meniscus is below the first 4 lines, so that would be 2.4, and then the very last digit is where the estimation comes in. So it really is an estimation, but you try to make your best guess. So I would say 2.46, but again that's going to be an estimate that you would have to do yourself, and perhaps you might say 2.45. As long as you're consistent, then that's fine. So I'm just going to record my initial burette reading as being 2.46, keeping in mind that we always put in the units. So in this case, I'm just going to put it at the top of the table as milliliters. So now I have my burette filled with my known molarity of sodium hydroxide. The acid sample that we're going to titrate has been previously pipetted. So sometimes we pipette the samples, other times we weigh them by mass so that we know exactly how much of the sample that we're using. And then lower the burette so that the tip of the burette is inside the beaker to prevent any splashing that might occur once you start titrating. So 2 more important things that we have to add is the indicator. So in this case it's a strong acid, strong base titration, so phenolphthalein is a good indicator. So I'm just going to add, in this case, 4 or 5 drops of the indicator. And then the next thing that we want to add is a stir bar. So the stir bar just gets slid down the side of the beaker gently to avoid splashing. And what that does is keep us from having to constantly swirl the flask, which you would have to do if you didn't have a magnetic stirrer. So to turn on the stirrer, just gently turn on the magnetic stirrer. There is a little bit of a pause. So turn it on very low at first until you see what the stir bar is going to do. Sometimes it will actually start to hop all about inside the beaker. So that's a pretty good stirring rate. You'll have to monitor it as you do the titration. So before you start your titration, always make sure you have your indicator, your stir bar, and your initial Buret reading has been recorded. So to do the titration, just open the stopcock and allow the solution to flow into the beaker. And what you should see very close to where the solution is entering, as we get further in the titration, you should see a very small localized color of pink, and that's the indicator changing color within that small region where the sodium hydroxide has not yet had a chance to react. And then as the titration proceeds, that pink color becomes a little bit more persistent. And you can see it stays for quite a while there, so if we turn off the stopcock, it will dissipate, so we're back to our colorless solution. So at this point, you might want to go a little bit slower, but you don't have to go quite drop-wise yet, maybe just fast drops. And so with the fast drops, you can hopefully see that the pink color is still staying, but it is dissipating if you just give it a few seconds. It takes a little bit of technique just to get used to using the stopcock, so the first few titrations will generally be overshot, but you get used to the Buret after a little bit. So at this point we're getting pretty close to the end because we can see that the pink color is staying for a little bit longer as we add drop-wise. So what I'm going to do is stop the titration, and I'm just going to take a deionized water bottle and rinse down the sides of the beaker. So that just takes everything that would have been in the flask down into the bottom of the solution so it can be reacted. For certain titrations we don't do the rinsing process, but that depends on the individual experiment. For most titrations we can just rinse down. So at this point I'm going to go a little bit slower, and it is a bit tedious, but that's kind of the nature of titrations, unfortunately, is it takes a bit of patience. So that last drop took quite a while to disappear, so I'm going to just try to add one drop at a time. So that's one drop. And again, it took about 5 seconds to disappear there. I'm just going to speed up my stir bar slightly. And that one again took about 5 seconds to disappear, so we're getting close. An end point is when you have a very pale pink, in the case of phenolphthalein, that stays for 30 seconds. So that means that it has had some time to homogenize and react, and it's still not fully reacted, so it stays pink for at least 30 seconds. I think that one might stay. No, I am mistaken. So the last few drops are the most tedious because you think you have it, but then it disappears. So this one may stay, or it may take one more drop. So kind of counting in my head here, and I think it's going to disappear. So I'm just going to add a very small amount. If I can add a half drop, some people can get the technique such that you can hang a drop at the end of the Buret, and then what you do is just gently touch the beaker to the side, and you can actually wash down that half drop. So I think that's going to be our permanent endpoint for 30 seconds. If we count to 30 or just wait for 30 seconds, you'll see that it actually does stay. So it is a little bit darker than I would hope. It should be just a pale pink, but it's not very, very dark. So I think this would be sufficient. So we're just going to wait and make sure it stays. And I think after talking there for a minute, it will. So I'm going to take the Buret reading. In this case, you don't have to take the Buret out because we can get our eyes at 90 degrees rather. by just bending over and seeing it that way. Just might have to move it around a little bit so that you can get your meniscus reading card right behind there. And in this case, you just have to move it right up. So now the meniscus is sitting between the 38 and the 39 milliliter mark, so it's definitely 38. And it's between the 0 and the 1, so 38.0. And the last digit is estimated, and I would say 38.03. But again, that last digit is definitely an estimation. So if I write down 38.03 as the final Buret reading, then we subtract those two Buret readings in order to calculate the volume of sodium hydroxide that was dispensed, and that gives us a volume of 35.57. You'll note that the initial Buret reading had 3 significant digits, but only 2 decimal places. The other one had 2 decimal places as well, so that means our final answer should have 2 decimal places, which does end up with 4 significant figures, but because it is subtraction, it goes by decimal places. So that's the end of our titration video.